And then the second presenter is my colleague Tayfun, who is going to give you a tutorial on IPv6 security.
So actually, I have a few questions about the last presentation, but I keep them for the coffee break, or I hope that you're coming to the dinner, so maybe I can ask. As the developer of the advanced IPv6 course and the owner of the IPv6 courses, I'm very curious about this experience in Vivacom network, and yeah, it's a very good example of it, deploying IPv6. Thank you very much for the good presentation. And now we are together with IPv6 security. So it will be about an hour session about IPv6 security. And this is actually a shorter version of our full day course about IPv6 security. So let's get started with it. But before starting, maybe I can introduce myself once again. I'm Tayfun Ozaltin. I'm working in learning and development team of RIPE NCC, and as a technical trainer and training material developer. Yeah, we are starting with the IPv6 security now. So this is the agenda for this 1 hour session. So first we will talk about the IPv6 security versus IPv4 security. Then we will see the reachability of IPv6 addresses. Is it different than we are used to? And the third topic will be about network scanning in IPv6. Is it available, or can it be done? Attacks on IPv6 will be the next. We will compare the protocol details of IPv6 and IPv4 later. And IPv6 support will be the next topic. IPv4 only networks, and the last topic will be about the IPv6 security resources we have already available. So let's start with the first one. At the beginning of each session, I will show you some statement that is believed to be true. So, and then we will discuss the reason behind it, and we will also check the reality. So the first one is coming. IPv6 is more secure than IPv4. And IPv6 has better security, and it is built in already. So what do you think about this? The reason behind this is the coming from an old RFC. It is IPv6 node requirements, and IPv6 is a must, it was saying. But actually, this is not true anymore, because we have a newer RFC which is stating that IPv6 is should. So it is an optional thing right now. Just like in IPv4, we can use IPsec in IPv6 as well, but it is an optional thing. So you can use it, or if you don't want to use it, then you can just don't use it. And IPsec is available just like it is available in IPv4. The reality here is we need a change in our mindset. So IPv6, the reality is IPv6 is not more or less secure than IPv4. And we always say that knowledge of the protocol is the best security measure. And because if we know more, we can protect our networks more in a proper way. And for a good level of security, again, the first thing is knowledge. And then we need to always remind ourselves that IPv6 security is a moving target. So you cannot just say that, okay, I secured my network now, and I can just skip that part from now on. No, it is not the way. So you need to follow the new threats about it. You need to follow the new security measures against the threats. So you need to be following this. It's a moving target. And the third thing is IPv6 is already happening. We all know that it is happening, and we have just seen that in Vivacom presentation. It is happening now. So 1/3 of the customers, and also maybe half of the traffic, is going through the IPv6 in networks that is enabling IPv6 now. And in the fourth item, we can say that cybersecurity challenge, it is scalability. So we should know that the IPv6 is the future of internet. We need to do it. We need to implement this. So there is no way around. So the second statement here is IPv6 has no net. It is global addresses used. and I'm exposed to attacks from internet. What do you think about this? So the reason behind this is the end-to-end paradigm we have, the global addresses, and we don't have NAT. So this statement is partially true. So normally in IPv6, we don't use NAT. And but this doesn't mean that it is not secure anymore. It is our responsibility, actually, to protect our networks at the edge of our network. So the global addressing, we have the global addressing, and we have the end-to-end paradigm back. What does it mean, actually? So IP protocol is designed to be end-to-end. So if you send some packet from Bulgaria to United States, that shouldn't be changing the IP addresses normally. But we broke this with the NAT devices. So we are constantly changing the IP addresses, the source addresses and destination addresses, we are constantly changing them with the NAT devices. This shouldn't happen normally. And finally, with IPv6, we are bringing this paradigm back to the internet protocol, to IP. And actually this slide is nicely showing that. So if you would like to make a communication between the countries and all over the world, the main paradigm should be end-to-end. So it shouldn't be changing. Can you read this number over here on top of the slide? I checked this and it says that, I can't read it, but it's something like trillion times sextillion or something like that, but it's not readable. So this many addresses we have in IPv6. So that is why we could bring end-to-end paradigm back into IPv6. Because we have lots of addresses, so we don't need to use NATs anymore. And the one thing that we need to pay attention here in this slide again is we have /64 for each subnet. So from now on, while you're using the IPv6, the number of the hosts will not be important for you. What is important is the number of the subnets. Because for each subnet, you need to assign at least a /64. So that is actually a change in the paradigm again. So you will not count the number of hosts in a network, but you will count your subnets. And you may have lots of addresses, different addresses in a single interface, like multiple addresses. Link local, global, and multicast addresses can be on the same interface. And another new thing in the IPv6 is we have actually scopes in IPv6. So we have link level scope, we have interface level scope, site level or global level scopes. And you can see, this means that actually how far this IP address will be valid in that scope. So it means that, for example, if an IP address is in an interface scope, it means that that IP is only valid on that interface. If the scope is the link local, then that means that that IP address will be valid on that link only. What about the global scope? Of course, we do have global scope addresses, and that means that it is valid on all over the internet. So that is actually why we have end-to-end paradigm. And you can see some examples over here. For example, the addresses starting with FE80 means link local addresses, so the scope is link. And what about FF addresses? They are actually multicast addresses, and their scope can be defined according to the next two digits. So FF01 means that it is interface scope because it is followed by 1. FF05 means that it is a site level scope because it's followed by 5. FF02 means that it is a link scope because it's followed by 2. So each address starting with FF is a multicast address in IPv6, and you can define the scope with the next two digits. And what about the 2001? You will recognize it, I believe, if you are dealing with IPv6 already. Then it is actually global scope. So you can communicate on all over the world with this IPv6 address. And FD is ULA. It is something like similar to the private addresses that we have in IPv4, but not really. There are some differences. And it has also the link scope. So we do have scopes in IPv6. There are some also other reserved and special IPv6 addresses, and if you would like to have good level of security in your networks, you need to be aware of all of these. So, for example, we have unspecified address, which is actually :/128, and this is only valid in the initialization of the communication, in the IPv6 communication. So you shouldn't be seeing this one, for example, in any kind of communication in your network after the initialization of the connection for any hosts. Or if you, for example, if you are not using 64 or if you are not using Teredo transition mechanisms, then you shouldn't be seeing these IPv6 addresses, special IPv6 addresses in your network. So if you would like to have some kind of good level of security in your network, you need to be aware of all of these addresses over here. So I don't want to go to details of each one here, but yeah, the more you know, the more your network will be secured. And we have some security tips for you, of course. We always recommend you to use hard-to-guess IIDs. So we have a new term here, IID. So it is interface identifier. We split IPv6 address into two parts. The first part is the network prefix, 64 bits, and the last part is another 64 bits. It is called interface ID. So the first one will be determined by the network, so it will be assigned. But the last part will be determined by the hosts, either with Slack or maybe with manual configuration, DHCP, whatever it is. But we always encourage you to use hard-to-guess interface identifiers. So we have some techniques here, and the recommended technique here is this RFC 8064, and we will come to the details of this one in the next slides. We also recommend you to use IPS and IDS. I know that it requires some investment on this, but it will worth it with IPv6. So you need to filter packets where appropriate and as close as possible to the edge. And be careful with the routing protocols, not to leak your routing protocol information into the local networks or the host networks. And also always use /64 size IPv6 subnet prefix for the subnets. So those are the recommendations. Filtering in IPv6 is very important. We already said this, but we have an advantage here. So we are starting from scratch, right? We don't have any IPv6 in our networks now. So for example, you can group some of your devices in your data center, and you can give them a /48, for example, and in your ACL or maybe in your firewall, you will have just a single rule for all of them. So this is an advantage. With this, you will have easier filtering in the networks. So you should also take into account the new filters that we have in IPv6, because we have new protocols in IPv6. For example, ICMPv6 or IPv6 extension headers. Those are new concepts. Fragments filtering. Fragmenting is not a new thing, but the way of implementation of fragmentation in IPv6 is new. And also the transition mechanisms. We don't have any transition mechanisms before IPv6. So you need to be careful about ICMPv6 filtering, because it is in the heart of IPv6 communication. So we do have actually many protocols that are running on ICMPv6. So you cannot filter ICMPv6 at all. So if you would like to filter ICMPv6 without any exception, then probably you will not have any communication at all with IPv6. So this is the recommendation table actually for you for filtering ICMPv6 in your networks. So those 4 types, destination unreachable, packet too big, time exceeded, and parameter problem messages in ICMPv6 should be allowed because they are error messages in ICMPv6. And also, if you would like to filter more, or maybe have some rate limit on it, we have some more recommendations. For example, type 128 and type 129 are echo reply and echo request messages. So you may want to have some filtering on them, but you need to rate limit them. If you just want to have some troubleshooting tools available for you with like ping and traceroute, you cannot filter all of these messages. But as a security countermeasure, maybe you can rate limit them as a wise decision. Or for example, for MLD, it is multicast listener discovery protocol that is used by IPv6 again. If it is going through the firewall, then you should allow these messages because they are used in IPv6. And also the same goes for the NDP, neighbor discovery protocol. If you are using NDP through firewall, then you need to at least allow the first 4 messages of NDP. What are those messages? Actually, router solicitation, router advertisement, neighbor solicitation, and neighbor advertisement messages should be allowed. So those kind of recommendations will be good for you while you are configuring your filters in IPv6. And also, when it comes to the filtering extension headers, your firewalls should be able to follow the chain of headers. So in IPv6, we have the new concept with extension headers. So it means that actually the basic header will hold the information, the default information in IPv6. And then if you need some extensions, you will do it with the extension headers in IPv6. Then if you are using extension headers, your firewalls should be able to follow them. And they have an order. So your firewall should be aware of that order, and you need to be filtered based on extension headers as well. Your firewall or security infrastructure should be able to recognize those different kinds of extension headers. So for example, there is a threat about routing header 0 and it is deprecated. It is not used anymore. Your firewall should be able to recognize this and should be able to filter, drop those packets. And it should also not allow forbidden combinations of headers. So what about filtering the fragments? So fragmentation is a little bit different in IPv6. How do we do it actually? So normally in IPv4, we do it hop by hop. So you can just fragment packets on each hop. But this is not the case anymore in IPv6. We just do the fragmentation on the source node and the defragmentation on the last one, in destination node. So you need to be careful while carrying those fragmentation extension headers. So what are the threats? Upper layer information, not in the first fragment. If it is the case, it creates many tiny fragments to go through the filtering detection. So they are the packet is trying to be hidden in the communication, and it tries to bypass your security infrastructure. So this is the case. The second case, fragment inside fragments. So you will have several fragment headers in a single packet. This is another threat. And fragmentation inside the tunnel. So it can be a valid scenario as well, but you need to be careful about it. So what are the countermeasures against them? If upper layer information is not in first fragment, it should be dropped because it is not allowed. If there are fragments inside the fragments, should not happen in IPv6. it should be dropped, it should be filtered. And what about the tunnel fragmentation? Fragmentation inside the tunnel, let's say. Then your firewall IPS or IDS should be able to deeply analyze those packets to see what is going on inside the tunnel. So your firewall should inspect the encapsulated traffic. And what about the filtering the transition mechanisms or dual stack nodes communication, let's say? Then you may need to know different kinds of properties about those kind of traffic. For example, for native IPv6, if you would like to filter it, you will probably need the ether type of it, which is 0x86DD. Or if you would like to filter some packets which are carrying IPv6 inside IPv4, then you need to know the protocol, IP protocol number of it, which is 41 here. So there are protocols here. And you can check these protocols. If you would like to have a good filtering, you need to know about this. And you can check all of this information in the RFC 7123. So maybe this is the key message of this slide. You don't need to pay attention to different rows of the table, but take the RFC number because it is important. And IANA protocol numbers also listing the protocol numbers, and you can check them. So what do we say about IPv6 packet filtering? It is much more important than IPv6. There are some common practices with IPv4. For example, if you are filtering based on the layer 4 information, then it is same in IPv6 as well. And also we need to be aware of the new IPv6 considerations, which are end-to-end needs filtering. ICMPv6 should be wisely filtered, as we just talked. And also, filtering should be adapted to the new concepts in IPv6, just like extension headers or the transition mechanisms. IPv6 networks, the third statement here is IPv6 networks are too big to scan. So what do we say about this? The reason behind this is the common LAN-VLAN use of /64 network prefix. So it's a huge address space actually. So this is also partially true because it is not easy to brute force the /64 network. But the reality is there are some new smart scanning techniques that the attackers can use. Let's check them. But before checking them, let's be specific on the different parts of the IPv6 address. So as we just talked in the previous slides, there are two parts in IPv6 addresses. The first part is network prefix, which is assigned by the network operator or the network. And the second part is interface identifier. So how does the attacker collect information about network prefix first? Because they need to, if they want to attack you, they need to know both parts of the IP address. So the first part is network prefix, and they can get information through the common patterns in addressing plans. So for example, you may be using the common patterns in your addressing plans, and they can also get information from the trace routes, for example. It is very simple. So you can send some ICMP packets through the network, and you will get information about the network prefixes that are being used in that network, and also from the DNS direct and reverse resolutions. So for example, they can make some brute force attacks to the known pages like index.php or index.html, so those kind of pages, and they can get information through those actually questions or the tools. What about the interface ID? It is not that easy to get the interface ID part of it. So brute force is no longer possible actually. So for the network prefix part, we can get some information, but for the interface ID part, it is a little bit changing because it's not that easy. So in order to generate the interface ID, we have several options here. The first one is modified EUI64, which is using the MAC addresses. So this is based on your MAC address. So in this algorithm, we use the MAC address that the host is using. So since we are using the MAC address, you can also imagine that it is the stable address. And also we have temporary address extensions, which also said in the name, it is temporary. It is changing over the time. And also it is changing from network to network. If you connect to this network, it will be changing. If you just unplug and connect to another network, it will be changing. So it is a temporary address. And also we have another option just in between those two, stable semantically opaque addresses. And that's this algorithm that we say it is the recommended one because it is stable first. So first of all, you will need somehow stable addresses in your networks as well. So this algorithm just provides this one. And it is also semantically opaque. Semantically opaque means it is not directly matched to any identifier in your host. Remember that in modified EUI64, it is directly matching to your MAC address. But in this one, it is not matching to any identifier on the host, so it means semantically opaque. And there are also ways to do it, DHCPv6, or you can assign it manually, or you can use other algorithms like CGA, which is cryptographically generated addresses, or hash-based addresses. So you can use many different algorithms. So there are lots of algorithms. So how can we, or how can an attacker know what interface identifier you use? So now we are coming to the point. Now we are checking what the attacker thinks about your interface identifier and how do I know those addresses. So the first one is about the EUI64. If you are using this algorithm, it is very easy for them because as you know, the MAC address can be split into two, and the first part is related with the vendor part. And there are just a few vendors in the world right now. So they can already know the first 24 bits of your address or interface identifier, let's say. And then in that algorithm, we put FFFE, that is the exact value of it, FFFE in between two different parts of your MAC address. So it means that for the attacker, to learn your 64-bit interface identifier or to guess your 64-bit identifier, it is easy because 24 bits are already revealed and FFFE is also revealed. 40 bits are covered. And now it can attack to the last 24 bits. And it is much more easy than 64. And also they can use the low bits. So if, for example, in your network you are using the first IP address that is available in that prefix for your network equipment, then this will be easy for you to remember, but also remember that it will be easy for the attacker. And you can also use some IPv4 based addresses. This is actually a valid usage of valid notation of IPv6 address. So many of the operating systems will be just converting this one to the hexadecimal version of the last part. So it means that it will start with 2001 colon db8 colon 1 colon, then the last part, which is seeming like the IPv4, will be converted to the hexadecimal. And if you are using the same addresses with your IPv4 hosts, the attacker can collect information on the IPv4 network and can attack your IPv6 network with this information. What about the service port? For example, for your web servers, you can use colon 80 address. It is convenient for you and it is also easy to guess for the attackers. Wordy addresses like bad cafe, it is fancy, right? It is good, but it is also easy to guess. And also sequential addresses. So if you are using, for example, the address structure like starting from 1 up to 100, and for each of them you are using one of them for your network equipment in the core network or in the backbone network, then it will be easy for the attackers to guess one of them. So those are the smart techniques that attackers can use to attack your network, to guess your interface identifiers. And also there are some more information for them to collect from your network, but in this one, they need to be connected to your local network. That is the most important part. So the best way to protect your network is not allowing attackers in your local networks. So I know that it's some kind of not easy thing, but yeah. And the fourth statement is IPv6 is too new to be attacked. So I think we all agree that this is not true. This is coming from lack of knowledge about IPv6, and we already have seen that it's happening. So there are tools, there are threats, there are attacks, security patches against IPv6, and also you have to be prepared for the IPv6 attacks. So if you are not still convinced about IPv6 is happening, then you can check this diagrams here. So for example, on the left-hand side, you are seeing a table taken from the Akamai website, which is actually content provider. So you can see that there are countries which are reaching to Akamai services with more than 50% IPv6 traffic. So for example, we can say, okay, Bahrain is a small country, but they are doing very well with IPv6, and 100% while reaching to Akamai web services, they are using 100% IPv6 traffic. Or the Saudi Arabia, India, Uruguay, France, Malaysia, Germany, Greece, so they are all above 50, and it is increasing. And also on the right-hand side, there are more graphs for you to be convinced about IPv6 is happening, and maybe I can explain the last one here, which is lower right corner. So it is taken from the Google website. So on all over the world, people or the traffic that are reaching to Google services is 40% IPv6. So it is already happening. And also there are threats about IPv6 as well. So you can check that this is an old graph actually. We couldn't find the latest version of it, but it is still good to check. So there are some unwanted email and web traffic with IPv6 addresses. There are some suspect traffic analysis. There are some virus threats about IPv6 or with the IPv6 addresses. So the threats are also real. And the fifth statement here that we have, IPv6 is just IPv4 with 128 bits addresses. There is nothing new. So the address space is enlarged, it's extended, but it is the same thing. Actually, this is not the reality, because the reason behind this statement is the routing and switching works in the same way. So there is nothing interesting to check with routing, because we are still using the longest match rule. So we are having the packet into the router, and we are checking the destination field of it, and we are checking our routing table, just directing it to the correct interface according to the routing table. And it is working in the same way in both IPv4 and IPv6. And we believe that this is the idea, or this is the concept behind this idea. But the reality is we have whole new addressing architecture with IPv6, and also many associated new protocols in IPv6. So for example, we have parts which is not changing with IPv6, which changes slightly in IPv6, or there are new also concepts, just like we have seen the extension headers, ICMPv6, NDP protocol, MLD. Those are the new protocols associated with IPv6. So for example, the IPv6 extension headers. So this is the mostly used IPv6 extension headers in the IPv6 communication. We have the basic IPv6 header, and those are the extension headers, can be followed by basic extension header. But here, there's a trick. They are extension headers and they are optional. So it means that actually, if you need those extension headers, you are using it. And if you don't need them, you are not using it, you are skipping that header. But they have a strict order, just like you see here. And they are followed by the upper layer protocol header. So what does it mean for you in the security aspect of it? Flexibility, because we are using it if we need that header, and we are not using it, we are skipping it if we don't need it. So it means it is flexible, but flexibility means complexity for your security infrastructure. And your security devices must process the full chain of headers. They should be able to follow the chain of header. And firewalls must be able to filter based on different extension headers. So they should be able to recognize all the extension headers, and they need to be they need to be able to filter based on the extension headers. So I would like to give some examples about the extension headers. The first one is a routing header, for example. So with this header, you can tell the packet to visit some nodes or some IP addresses along the way. So, but what is the threat with this header? It is a special type of it. It is routing header 0, type 0. So, and what is wrong with this header? Actually, this is found very dangerous for the networks, and it is deprecated. It is not used right now. And what is the scenario about it? This diagram is explaining it in a very well way. So we have the attacker here, and we have the packet, which is sourcing from S and going to D, which is the destination address. And in routing header type 0 field, you see that there are some segments that this packet should visit along the way. And it is going from A, B, A, B, A, B. So it is following the same pattern till the end, which is actually 127th field of it. So it means that this packet will bounce between the nodes A and B till the end of 127 fields. And it is very dangerous because it can just increase the usage of bandwidth between the hosts A and B, and it can be done remotely. So since it is found dangerous, it is deprecated now. It is not used, and your firewall should know this. And as we say, use of RH0, routing header 0, is deprecated, and your security infrastructure should check it properly. And what about the threat with fragment header? I will also try to give some examples about this header as well. It is used, as you already know, maybe it is used by IPv6 source node to send packet bigger than the path MTU. So please pay attention to the last two words here, path MTU, we say. In IPv4, there is no concept like path MTU. It is the MTU. But here in IPv6, we use path MTU because right now it is important to know the MTU of the whole path. And it is the lowest MTU throughout the path. So it is very important because we are doing the fragmentation in the first hop only in IPv6. And what are the threats about fragmentation? There may be some overlapping fragments, which means that actually while you are sending fragments, you are marking the packets or the fragment parts according to the relatively, with a number relatively determined according to the fragmentable part of the packet. So I know that it is complicated. I will explain it in a minute with a better slide. So not sending the last fragment can be another type of attack. So waiting for the last fragment can consume your resources, and it can be a threat for your network. And also there are some atomic fragments which can have some valid usages in some networks, and this can be another threat for your network. So what about the overlapping fragments? So this slide explains this in a better way. So let's think that in a normal situation, we are sending the packets from the source to the destination. Let me just show it to you. Here we have the packet, the original packet, and it is fragmented like this. So in the offset field of the fragmentation header, this one says it is 1, so it means that it should start, this part should start from the first, the beginning of the packet. And this one will be followed by 201. So it means that this packet is covering 200 bytes, and this is starting from the 201st byte. So this is the normal way of doing fragmentation. And when the packet is received by the destination here, it can be defragmented properly. But if you do this in an attack way, then you can do like this. So here again we have two different parts of the packet, and the offset field for the second packet can be wrong. And at the end, while you are defragmenting this, it can be overlapped. And this makes some operating systems to throw some exceptions. And also this is dangerous for the operating systems. So this is another type of attack that can be used by the attackers in different networks. And what can we do about this? If there is overlapping fragment, it is not allowed. If they are not sending the last fragment, then you can set the timer and discard those packets, and normally it is 60 seconds. So at most you can wait 60 seconds. There can be some atomic fragments, and they should be processed in isolation. Atomic fragments means actually the only fragment, only part of the fragmented packet is just one packet. So it means that there is no other part, there is no other fragment part, and you are using it for determining some MTU for the transition mechanisms from IPv6 to IPv4. So some translation nodes in between can use these atomic fragment fields. And what about bypassing array filtering, array guard? Array guard is a very important, actually, countermeasure against the attacks about the array messages. So the attackers can send some rogue arrays or bad arrays, let's say, in your network. And if they are sending it with some headers, extension headers, just before the array header, then, and if your security equipment is not checking those headers properly, then it can bypass your security infrastructure. And what else we have more? You can use another type of attack with the fragment header, fragment extension header. The attacker can just split packet into the fragments and send it to your destination, to the destination. Then it can also skip or bypass your security infrastructure. So for those type of attacks, we have fragmented NDB packets. It is forbidden. You shouldn't be using, or you shouldn't be allowing to use it. And also the other attacks based on extension headers, it is the header chain should go into the first fragment. It is also stated in RFC 7112. And you can also check the RFC 7113 for the other types of attacks. What about the NDP features? It is the protocol in the heart of, again, the IPv6. So it has some kind of embedded security in it because it is using the hop limit 255. It actually proves that that packet will remain in the local network. So the hop limit is 255. You cannot send it out of the link local scope. So that's why it is considered to be an embedded security somehow. If not, it should be discarded. If it is an NDP packet and if it is not carrying hop limit 255, then it should be discarded. And NDP also has some vulnerabilities, and they are stated in RFC, in those two RFCs that we are saying here. It is RFC 3756 and RFC 6583. And also, we have some specifications saying that we should use IPsec in NDP, but it is not practical, it is not used. Send also another version of NDP. It is secure version of NDP, secure NDP, but it is not widely available again. So there are some more threats about NDP. So you can poison the neighbor cache of the hosts in the network with some rogue neighbor solicitation or neighbor advertisement messages. So if you can spoof those messages, so you can change, if you can change the IP addresses, the source IP addresses, you can do it. And it can be done in two ways. So with neighbor solicitation message, you can change the source link layer option. And with the neighbor advertisement message, you can change the target link layer option. What does it mean? So you can think that it is like ARP poisoning. So in IPv4 networks, if we would like to make an analogy with IPv4, it is like the ARP poisoning. What you do here, changing the IP address corresponding to the different MAC address in the host network, so that the attacker can receive the packet to itself in the local network. It is the neighbor cache poisoning. So the attackers can use it to redirect or denial of service attacks, these kind of attacks. They can use it, and they can also use it as the man-in-the-middle attack. So if you can achieve to attack both source and destination, then you can be in the middle by poisoning the neighbor caches of both source and destination hosts in the network. And the sixth statement here is IPv6 support is a yes or no question. So actually this is not the case because IPv6 support is a set of questions or a list of questions, list of yes or no questions. So it is not enough to say that this node is supporting IPv6. It doesn't mean anything. So what you should say, it is supporting this RFCs or this features of IPv6. You should be able to say that. And for that reason, we have a very good document in RIPE NCC website. It is ripe.net website. So you can search in also Google, you can search like RIPE 772, and this document lists the features that you need according to the device type in your network. It is very useful, especially useful when you are preparing your RFPs. For example, you are trying to buy some equipment, a new equipment, and you would like to list the RFCs that you want to be supported in your new equipment about IPv6. Then you can use this document. For example, if you are buying a host device, then these features should be supported. If you are buying switch, you can list those RFCs or those features to be supported. What about router? On top of host features, you can list other RFCs about routers here. according to the protocols that you use in your network. For example, if you are using OSPF version 3, then you can select those RFCs about OSPF version 3. And it goes on like this, and it is very well structured, and it is very handy document for you to prepare your RFPs about IPv6. And in the 7th statement, it says that IPv6 is not a security problem in my IPv4 only network. So we are all using IPv4 only networks. Maybe if you are not making the deployment in IPv6 and right now, you are using IPv4. And it shouldn't be a problem for you, the IPv6 security, right? It's not your concern. But actually, I am sorry, it's not true. So the reason behind this, we always think about our networks and we are not aware of the threats, new threats about IPv6. But in the reality, IPv6 is already available by default on many operating systems right now. So it is available off the shelf. It is available on hosts, on servers and devices. And unwanted IPv6 traffic may happen in your IPv4 only network. And you need to be protecting your network. In IPv4 only infrastructure, you can expect some dual stack hosts without you knowing this. So VPNs or tunnels can be established. Undesired local IPv6 traffic can be seen, or automatic transition mechanisms may happen. For example, I remember that in Windows 7, Teredo or ISATAP was coming enabled by default. And you can also have problems with some rogue arrays. So we have seen in the previous slides the rogue arrays. Array is a very powerful packet in IPv6 network actually, because it is carrying many information from the router to the hosts in the network. And it is actually configuring your hosts in your network against for the IPv6. So, for example, it is carrying the prefix information. It is carrying the default gateway information for the hosts. So it is very important. And if you have rogue arrays in your network, bad arrays in your network, then it's a problem for you. And what can you do about dual stack? So what kind of threats you can expect about dual stack? First of all, the attacker may have bigger attack surface because right now you are using two different protocols, IPv4 and IPv6. The address in IPv6, normally, unless you filter them properly, they are globally reachable. We call them GUA addresses or global unicast addresses. And the attacker may also want to use one IP version to attack to the other. They can collect information from one version and they can attack to the other. What can you do about this? You need to protect IPv6 at the same level as IPv4. So that's why we always say that you need to have feature parity in your security equipments. For example, if you have some feature about IPv4 in your security infrastructure, then you need to have the same level of security feature for IPv6 as well. For the GUA addresses, it's obvious you need to filter at the edge of the network. And please don't trust your IPv4 only network. So the attackers may try to collect information from IPv4 and they can attack to IPv6 because IPv6 in most operating systems right now is coming on by default. So the last statement that we have here, it is not possible to secure an IPv6 network. So why are we here now? So it's an IPv6 security session, right? It's obvious that this is not true. So the reason behind this, again, lack of knowledge, we believe. You can consider IPv6 completely different than IPv4, but this is not the case. There are some common practices, but also we have different topics as well for the IPv6 security. In reality, you can use IP-independent security policies These are the common things with both protocols. And there are best current practices, resources, and features available for you. And when you compare IPv6 versus IPv4, there are some parts which are not changing in IPv6. Just like we said, the routing feature, for example, we are still using the longest match rule for the routing. There are some fields slightly changing with IPv6, and also we have totally new concepts in IPv6. For example, the extension headers, NDP protocol, MLD, whatever it is. And you have lots of tools available for you to assess your networks against the IPv6 security. So those are just a bunch of them, and I'm sure that you can find more, but we try to list all the open source and free, mostly free tools that are available on the internet, so you can make use of them. We have packet generators here, we have packet analyzers, specialized toolkits for the assessing the IPv6 security, or we have scanners. Maybe you know them from the IPv4 security topics. And we also have some open source IDS and IPS softwares like Snort, Suricata, or Zeek. So there are lots of tools available. Don't worry about it. And also we have rogue array solution. We said that array is a very powerful message, very important message in IPv6. So actually you need to be aware of the rogue arrays in your network, and you need to protect your network against them. There are some available solutions like link monitoring, send, manual configuration, host packet filtering, router preference option, or ACS on switches, but none of them are as useful as the last one. Array snooping on switches. And this is the key message of this slide. So you need to be aware of this solution. It is called Array Guard, especially on Cisco. I think it's called Array Guard. So you need to be aware of this solution. So in this version of the solution, the switch learns about the source of the arrays, the valid source of the arrays, and it blocks the other ways, the other ports to send array messages to the network. So that is the most useful way of doing it. And I'm sure that there are lots of vendors doing this already with the switches. And they are called first-hop security features. Why it is called first-hop security? Because normally in a network, in a local network especially, the switch will be the first hop. And this is called first-hop security features. So you can search with these keywords. And there are a number of techniques available, like array guard, IPv6 snooping, IPv6 source and prefix guard, IPv6 destination guard, MLD snooping, and DHCPv6 guard. And they are all protecting you against the security threats that we have in IPv6 networks, especially in the local networks. And what about the routing protocols? If you would like to protect your routing protocols as well, then you also have some solutions. This slide is showing us the authentication options in routing protocols about IPv6. Let's check one by one. RIP-NG. Actually, this one is not supporting any authentication options. So it says IPsec as the general recommendation, but IPsec is not available in practice. So it is not. It can't be recommended to use RIP-NG anymore. And also, what about OSPF version 3? It says again IPsec as the general recommendation, but it also has authentication trailer solution for it. It is RFC 7166, and it is the way of doing it in a proper way with OSPF version 3. So it is recommended to use authentication trailer. What about ISIS? We have two different options, HMAC MD5 and HMAC SHA. And obviously, MD5 is already outdated a little bit, and it is recommended to use SHA to protect the authentication in ISAS networks. And what about MPBGP? We have authentications options available like MD5 and TCP/AO. But as we said, MD5 is outdated and it is not used anymore. It's not recommended to be used anymore. And actually, the recommended way of doing it is TCP/AO, which actually works in two-phased operation, and it supplies or provides better security. So we talked about the authentication part of it, to authenticate neighbors in the routing protocols, but what about the routing updates to protect them? Actually, we only have OSPF version 3 for this security feature. So in OSPF version 3, in RFC 4552, it says ESP must be used with the manual keying, and unfortunately, no other protocol has this option to protect the routing updates that you send to the neighbors. So we have the authentication security option for the protocols, but for the routing updates, we only have that in OSPF version 3. And the conclusion here, we have security options available for IPv6 routing protocols, and you need to check them depending on the protocol that you use, and you need to protect your routing protocols at least at the same level as IPv4. So that's the idea. And by saying that, we are coming to the end, and I would like to promote our web pages here again. So we have academy.ripe.net. I know that these are a little bit confusing, and there is not enough time to explain all of these concepts here in 1 hour. So you can check them in more detail in our webpage, academy.ripe.net. And we have also full-day face-to-face course about IPv6 security, and also you can have this course available in academy.ripe.net page. You can check it. And also, if you would like to prove your knowledge about any of these topics here, like IPv6 fundamentals, RIPE database, BGP security, and IPv6 security, we have certification programs. It is getcertified.ripe.net. So there are levels on these certification exams. For example, it is analyst for IPv6 fundamentals, and it is expert for IPv6 security. So if you would like to prove your knowledge, you can also have one of these exams. They are available for you, and as being an LAR, you will have 3 different vouchers per each year for these examinations. And I think we are at the end of it. So thank you for listening, especially at the end of this day, this tiring day. You paid attention. Thank you very much. If you have any questions, yeah, I'm still available here.